Welcome to today's session on integrating VM workloads into Anthos Service Mesh. I'm Chris Crall. I'm a product manager in Google Cloud. I've been with Google for about 6 years, and I've been focusing on services most of that time, and for the last 2 years specifically on Anthos Service Mesh.
And I'm Sven Mawson. I'm a software engineer in Google Cloud. I'm one of the founders of the Istio project, and I've been focused really on expanding the reach of meshes to multiple clusters, and in this case, to VMs.
So before we get into the details of how we're integrating VM workloads into Service Mesh, I want to give a little background and a little motivation on why we're doing it. So one of the factors behind this is the microservice trend. This is a big topic in the industry. It has been for some time. And people talk about a lot of things about microservices. How when you break the monolithic application up into smaller services, your teams can move faster. They can even decide which language each team wants to write in. Some might write in Java, some might write in Python. It doesn't matter because they're broken apart and operate independently over APIs. They can roll out new versions on their own. They don't need to roll out the whole application at one time. It might be more scalable. They can swap out something has been purpose built for maybe a SaaS service. So there are tons of benefits behind microservices. But the bottom line is what you're trying to do is roll out new solutions for your customers. You're trying to get those solutions out there faster and make them better, either higher reliability, more functionality, whatever it is, you're trying to roll out solutions to your customers. However, this new architecture comes with some drawbacks as well, right? As you break things apart, and now your services are doing a lot more communication than they used to. So you have to know how they're communicating. You may need to secure that communication. Since the services are independent, then you may have them logging in different places, so it's harder to debug. So all these things can lead to some confusion, some downtime, and ultimately unhappy customers. So what can we do to solve this? Well, one of the things we can do is introduce a service mesh. Now, a service mesh I've defined here in generic terms, and it provides several attributes. One is, first off, it should be transparent. It should allow us to roll out a mesh and not have to go in and change application code. So you don't have to link in libraries and things like that. As we talked about with microservices, it should be language independent. So it shouldn't matter whether your component is written in Go or Java. It should work in the service mesh. And then you want that service mesh to be able to automate a bunch of things for you, whether it's network traffic or logging or whatever it is, it should be automatic. So those are the kind of things a service mesh can give you. So let's talk about the Anthos Service Mesh and what it does provide for you. Now, Anthos Service Mesh, and sometimes we use the acronym ASM, is built on top of Istio. It's powered by Istio, which is an open source project that Google started and it works on with multiple partners. We talk about three main attributes of Anthos Service Mesh. The first thing is uniform observability. So the idea is that we can collect metrics on all communication going on in the mesh. We know which services are talking to which other services. We know what the requests per second are between those services. We can find the error rates, and that can be done just instantaneously as well as over a time series. We can even set SLOs, both on availability and latency. So we have lots of information about what is going on in the mesh from a traffic perspective. Second, we have operational agility. So we are in the network and we can control that network traffic. So we can do lots of things. We can do canary deployments or blue-green deployments. We can do load balancing, and we can do load balancing with a variety of algorithms. For testing purposes, we can even do fault injection, so you can make sure your services are resilient. And we can even set quotas. The third attribute is security. So first, we have identities for the different services, and with those identities, we can get certificates. Once we have those certificates, then we can enable MTLS. So with MTLS, now we know which services are talking to which services in a secure cryptographic manner, and all the data can be encrypted across the connection, so nobody else can see what's going on. With MTLS, then, on top of that, we can set access control policies. We have simple things like allow and deny lists, but we have lots of other access control policies as well. So these are the three big areas of Anthos Service Mesh. So let's talk about how that plays with VMs now. So we've known from the very beginning that VMs were critical in the service mesh because 80 to 90% of the workloads in a customer environment are running on VMs or bare metal machines. Containers and Kubernetes provide a lot of wonderful benefits, but again, most of the workloads are still running on VMs, so it's critical we integrate those into the environment. In this diagram, I'm showing a high-level architecture of what the mesh looks like. So on the left is a Kubernetes cluster, and there are some control plane components running there, mainly the Istio sidecar injector, which puts proxies beside the pods for the services running in the cluster. Across the bottom, I'm also representing managed control plane components. These are Stackdriver for logging and metrics, Traffic Director for controlling the traffic, and the Mesh CA for certificates. But in the middle are the VMs. And again, this is what this session is about, is how we incorporate these VMs into this mesh. Now, there are a variety of reasons that workloads are on VMs. In some cases, that's just where they need to run. Databases have been tuned and run very well on VMs. Moving those to containers may or may not give you the same kind of performance. So a lot of times I see customers that are still running their data stores in VMs, and it makes a lot of sense. Second, we have packaged applications. So some vendors don't support their applications running in containers. So this particular company may have a ERP or a CRM application, and they have to run it on a VM. In fact, usually the vendor will tell them exactly what distro and what version of the VM they have to run. Most importantly, though, are probably the legacy applications. These are the applications that you've built to run your business. And those are still running on VMs. They probably will be for a long time. There's no way that a company has the budget, the time, and the engineers to move everything over to containers, even if that made sense. So VMs are going to be around for a long time. They're the majority of the workload, and we have to incorporate those into the mesh. So let's start diving into how we're going to do that. And we're going to talk about managed instance groups. Now, managed instance groups are a feature of GCE, and they are a set of VMs that all look the same and run the same kind of workload. So for example, if you have a web front end, you might want 10 VMs running that web front end. You might even want to auto scale. You're doing load balancing, things like that. So the way that managed instance groups are created in GCE is you first create a instance template. Now this template defines what the VM looks like. How much memory do I want? How many cores do I want? What kind of storage, what kind of persistent disks I want, what network the VMs are going to run on. All of those things go in the instance template. Once they're in there, the managed instance group is created, and the user tells the managed instance group how many VMs should be created. I want 20 VMs, or I want 100 VMs, or you can even do auto scaling. I want somewhere between 15 and 35 VMs. So the managed instance group will spin up the VMs and control how they're created. The wonderful thing about MIGs is because that managed instance group is controlling the life cycle, it can do health checks on the VMs and kill VMs that aren't working correctly and then restart them. Again, auto scaling events, if you have auto scaling turned on, it will start and stop VMs depending on the load. So what we're doing, and Sven will go into a lot more detail on this, is we're adding some features to the instance template so that when the managed instance group creates VMs, it adds the mesh software to them and allows them to join the mesh. So Sven is going to go into more detail now.
So I'm going to try to give a brief overview of the architecture of the system, and I'm going to use an example that we're actually going to be using in a demo later. So here we have a GKE cluster that's running Anthos Service Mesh 1.6, and it has the online boutique sample application installed in it. But we actually took out the product catalog service and we moved that over into a MIG instead of being running in a Kubernetes pod. And I want to talk a little bit about kind of how Anthos Service Mesh works and the services it relies on, because I think this is important to understand just how many different services are involved in making the mesh actually work the way you want to. So the first thing that happens when the MIG starts up is that it starts up this agent that's running in the MIG, in the VM, and that agent connects over to the DNS server running in Kubernetes, kubedns, and acts as a proxy for that DNS server. And this is used to give service discovery to the VM, just like you get service discovery in pods. So the same type of mesh services will be resolved to IP addresses in that mesh. The second service it talks to is the mesh CA, which is used to mint certificates for the VM. And the way that this works in practice is that the agent is actually acting kind of as a proxy. So it runs a secret discovery service that the proxy can connect to, and it proxies that over to the mesh CA, and it gets the CA certificates from there. So the agent then starts up this Envoy proxy that's running inside the VM, and the proxy is configured to talk to a control plane component. Here in this picture, it's Istio-D running in the cluster. And it's also configured to send telemetry over to Stackdriver. So this sends all of the logs, metrics, traces, and actually also edges, which we use for our topology graph, over to Stackdriver. And it, of course, connects to the agent for those certificates, so it can get mutual TLS bootstrapped. The application itself is then proxied via that Envoy proxy, and that can be done one of two ways. It's either using IP tables, which is a transparent proxying mechanism, or it can actually also be run in white box mode, where the application knows about the proxy and sort of manually interacts with it. ASM is also relying on the Kubernetes API server for configuration storage. That's actually not pictured here, but that's also another key component of the system. You need a place to store your configuration, things like service definitions, authorization policies, the routing information, basically all the configuration for the features that Anthos Service Mesh offers is provided in that configuration store. Okay, so let's walk through how we actually add this MIG to the mesh. And we're going to look at the 4 different steps here. So step 1 is configuring the VM's identity. Step 2 is starting up the MIG and connecting it to the services it needs. And then steps 3 and 4 are about registering that VM as an endpoint in the mesh and selecting that endpoint or all the endpoints that are relevant into relevant services. So let's walk through one by one. So the first thing we're going to look at is the identity space. And this gets a little bit complicated because on GCP, the VMs are actually running as GCP service accounts, not as Kubernetes service accounts. And these have a different form. So a GCP service account, there's really 2 different main ways that you'd run a VM. You can either use the default service account for the VM, which is just project number -compute, or you can use a named service account that you created, which is service account name at project ID. And these would be the identity that the VM starts up with and is available through the metadata server built into GCP. But in Anthos Service Mesh, we want to use mesh identities. So mesh identities are basically 3 parts. They are a trust domain or a workload pool, which identifies the source of the identities. And then they're a namespace and a service account within that namespace. And so we need to map between these 2. And ASM for GCE provides a default mapping that will map those service accounts from GCP over into service accounts in Anthos. We are also working on making this configurable so you can map into the namespaces that you want to rather than using the default mapping if that doesn't work for you. Okay, so now we need to actually get that instance group started and verify that everything is actually working. So we do this using the mechanisms that Chris was just talking about earlier. We use an instance template that we configure with the service proxy. We give it the configuration it needs to know what identity it needs to use, and then we connect it to the control plane components that I was just talking about. Once it's running, we can verify that it works correctly. We can check that it's connected to the control plane and is getting configuration. We can verify it has a certificate and rotation is set up properly. And we can make sure the telemetry is going over to Stackdriver and even go and actually look at that telemetry if we want to in Stackdriver to make sure it looks like what we expect. So we have this running, but we aren't able to actually call the VM yet. So we can't route traffic to it yet. So to get traffic to the VM, we need to register it. And in Anthos Service Mesh, we do this through a decoupled mechanism that's very similar to how pods and services work in Kubernetes. The equivalent in Anthos Service Mesh for VMs is workload entry and service entry. And a workload entry is basically a named endpoint in a namespace. It gives us a way to attach labels and attach a service account to an endpoint, and then that thing can be selected by the next thing we're going to talk about, which is the service entry. So a service entry basically lets us create named mappings to endpoints in the same way that you do with Kubernetes services, except that it can also select workload entries. So just like a Kubernetes service, it has a port, or a set of ports actually. It has a workload selector that says what endpoints are selected. And in ASM, we also let you specify the host as a generic opaque string. It doesn't have to just be a Kubernetes service. We can actually use other types too. But for using the same service as a Kubernetes one, you can just specify the host like we did here. Okay, so that's how this all works and the architecture. Let's look at a demo next. So in the demo, we're actually going to set up exactly the architecture I just talked about. And we're going to show off the three pillars of Anthos Service Mesh, the observability features, the agility, networking, and sort of traffic management features, and the security features. So we'll look at each of those in turn in this demo.
So let's see our demo of VMs running with Anthos Service Mesh. So in this demo, we're going to show the kind of three main pillars of Anthos Service Mesh: the observability features here in the form of the dashboards, the traffic management capabilities, which we're going to show a little bit of canarying of a new version, and the security features. And here we're going to show authorization policies. And this just gives you a little flavor of kind of what you can do with Anthos Service Mesh for VMs. It's not meant to be a complete demo of all the good things you get from it. So let's get into it. So the first thing we're going to do is look at what we have created so far. So we have a cluster here, a GKE cluster running Anthos Service Mesh. This cluster also has the online boutique sample application installed, except we don't have the product catalog service. So we're also running a managed instance group with 2 VMs in it, and they are running the product catalog service for the online boutique instead of running them in the cluster. So this can show you how you can run VMs combined with your Kubernetes services. But right now we don't have these things hooked up together. So right now this is failing because the mesh doesn't know about those VMs. So the first thing we're going to do is actually show that registration step. So we're going to create a workload entry and a service entry for the VMs. So let's look at these. So this is a workload entry for the product catalog service. It's the V1 of it running on an IP address. So let's go ahead and create it. And let's also look at the service entry for this. And this service entry basically says the product catalog service is all of the workload entries with the label selector below where the app is product catalog service. So this will select everything, and it's not actually using the version. We'll see what version is used for later. And this is basically the same as a Kubernetes service, except it can select workload entries as well as Kubernetes pods. So let's go ahead and create that. And now that we've created that, our online boutique should be working again. And there it is, it's working. So once we have this up and running, the first thing we get is all the telemetry features. So the telemetry, because there's load going through this service, all that telemetry is going to Stackdriver, and we can actually see it in the Anthos Service Mesh dashboard. So here's the dashboard for the product catalog service. We can see the request per second, error rates, latencies, CPU usage, things like that. You can also use all the other great features of Anthos Service Mesh dashboards, the health, ability to create SLOs, look at detailed metrics, look at connected services, do more diagnostic dives, that kind of stuff. So all the same features you expect, but now available for a service running in a VM. Okay, so the next step is let's do some traffic management. So we want to roll out V2 of our service. And the only difference in V1 and V2 is we're going to have a slightly different product catalog in this case. We're going to have different product description and a different price for this typewriter. So let's go ahead and do that. So the way we do this is we're going to create another workload entry. And here we use v2 as the version instead of v1. And otherwise it's the same, and we don't have to actually change the service entry. We just add a new workload entry, which is basically adding a new endpoint. So let's create that. And then we also need to create a destination rule and a virtual service. So let's look at our destination rule, which actually we're already running. So this destination rule just says that there's two subsets to the product catalog service. There's a v1 and a v2, and those are selected based on v1 and v2 labels. So very simple. And let's do a traffic split. So let's split traffic 50-50 between these. Now, normally you'd want to do like a 1% or a 0.1% or something very, very small when you're canarying a new version, but here we just want to show that it works. So we're just going to go straight to 50%. And now if we go back to our typewriter, if we refresh, we should be able to see, yep, there it is, a different version. So the product description changed, the price changed, it went up a lot. New version works with their typewriters. And if you keep refreshing, you can see sometimes it'll go to v1, sometimes go to v2. It just basically is flipping a coin and deciding which one to go. So let's say we're happy with that and we decide, yep, let's actually go full on v2. So we can do that. We have a virtual service that says, yeah, send it all to subset v2. And let's apply that. And now if we go to our boutique, our typewriter should always be on v2, and it is. Okay, so that's a really basic look at some of the network capabilities. Now let's look at our final area here, security. And so we already have MTLS set up, right? So these services are all talking to each other over mutual TLS. They each have an identity, they have certificates, they're all set up. But we're not actually preventing any access. As long as something has a certificate, it gets through. And so what we want to do is be able to say, only the services we expect to be calling are allowed to. So what we use is ASM's authorization policy to do this. And first what we're going to do is show an authorization policy that just locks it down completely. So that's a good first step, although clearly you wouldn't want to do this in production directly. But we can deny all traffic to this product catalog service. And so all we have to do is create an authorization policy. It has a selector that matches that product catalog service, but it has no rules. So it doesn't allow any traffic. It just denies it all. So let's go ahead and do that. And once we deny everything, if we go look at our boutique, it gives an access denied error, which is what we'd expect. Okay, so what about actually allowing the traffic that we do want? Well, so here we have a different rule. This is, again, very simple. We have a rule that just says, if the principal that is calling is the default service account in the shop namespace, let it through and block everything else. So let's go ahead and apply that one. And now if we go look at our shop, it works again. And so that is basically what security looks like for Anthos Service Mesh with VMs. And so between that and the traffic management that you get from Anthos Service Mesh and the great observability features, you can see just how useful this can be for using virtual machines with Anthos Service Mesh. Thanks.
Thanks, Sven. That was a great demo. But I have a couple of questions I've received from customers. The first one is, what about a single VM? How do I handle that?
Well, so the great thing about MIGs, aside from all the great features they offer, is that actually they're free. So you can just take your VM and you can extract an image from it, which GCP makes very easy to do. And you can run that as a single VM in a single managed instance group. And again, that's free. There's no extra charge for that. And it's very easy to do. And then you can get all the great features of MIGs, including the ability to run a managed DOM.
Okay. And this is all great on GCE, but I have Anthos on-prem, and I want to integrate my on-prem VMs. How do I do that?
So we are actively working on making that both supported and very, very easy. It won't be quite as easy as we've managed to make it on GCE because we don't have the equivalent of managed instance groups. But we do have plans in place to release a version of Anthos Service Mesh with VM support for on-prem where you take a couple more steps than what we've outlined here. You would be responsible for generating the configuration that goes on the VM and installing the H&M proxy there. And we provide packages to do that. But then once you have that, everything else will be the same as described here. You can set up the same features. It connects to the control plane the same way, and you get all the great Anthos Service Mesh capabilities.
Okay. And one last question. What if I have just VMs? My department or division isn't using Kubernetes right now. I just have VMs. How do I set up the mesh with those?
So that is a excellent question. So during the architecture overview that I was giving earlier, I was talking a little bit about the different services that we need to connect to. And so 3 of those services were still running in the cluster. So there was the Istio control plane, there was the kubedns DNS resolver, and there was the API server used for configuration store. And the great news is we're working on managed versions of all of those. So the control plane, the managed version is Traffic Director, which is already available through GCP's APIs, and we're working on making it available through Anthos Service Mesh. For DNS, we're actively working with the Cloud DNS team to actually integrate the Kubernetes DNS serving and GCE DNS serving into a single system. So actually that will all be built in. You won't need to do anything extra. And again, it'll be a completely managed service. And then finally, we're working on making a managed version of the API server. So again, you don't need to run anything. You can just use the managed API server and use VMs with all of those components fully managed by Google.
Great. Okay. Well, thank you very much.
Yeah, great questions. And this was a lot of fun. Thanks very much.